Hello everyone, welcome back. So today I'm going to be talking about iron. So iron is something that's essential for your body. So it's not the iron that you find all around you, although it is similar actually, but you are not going to go and munch on the train tracks, for example. So iron we get from our food, and iron is in such a big variety of things that usually you're okay. But if you do not eat a wide enough variety of food, you can become deficient. So why do we need iron? So I'm going to go through why we need iron, what it is, where we get it, how it works in our bodies. And in the next video, in the 5 in 5 video, I'll talk about some sources. I'll quickly mention them here, but I will tell you in another video about the sources. So if you are interested in iron, if you want to know a little bit more about it, please stay. And at the end, I will give you some handy tips to increase your iron absorption in your body. So let's get into it. So iron. Iron is important for your body because it is the key ingredient in your blood. So your blood cell has a ring, and in the middle it has iron. So that is what makes iron so important, because it's a constituent of your red blood cells. And your red blood cells has to carry oxygen and nutrients all across your body and throughout your body. If the iron molecule is not there, this cannot happen. So oxygen and nutrients cannot be carried and transported through the body if there is no iron. So this is why iron is such a key component in our lives and in our diets especially. So iron is stored in your liver. So again, we come back to a lot of functions go back to the liver. The liver here is a key organ in your iron homeostasis or balance, and your liver is a storage facility for your iron. So iron is not excreted effectively, which means it can build up in your body. So there are some diseases where you have too much iron and you need to be bled out to release some of the iron because you are maintaining or keeping too much iron. So iron is mainly excreted in your fecal matter, in your poo or your feces, and your duodenum maintains the balance of iron in your body. So it regulates the absorption of iron. So depending on your balance, how much iron you have, your duodenum will send signals to absorb more or excrete more. So duodenal regulation is critical to your iron homeostasis or balance. So if there's something wrong with your signaling, you'll either have too little or too much. And iron also works in close connection to your intrinsic factor, as well as your pH, your acid in your stomach. So if there's not enough acid in your stomach, you cannot absorb enough iron because it has to go through that acidic medium to be absorbed. So we absorb around 1 to 2 milligrams per day to maintain the balance, because we also lose about 1 to 2 milligrams of iron per day. So it's not a lot of losses, and it's not a lot that we have to take in. So 1 to 2 milligrams you can get in a teaspoon of seeds, for example. So you can really easily get enough iron. So usually if you're not getting enough iron, there's another problem somewhere, or you are definitely not eating the iron sources. Okay, so how you lose your iron is through cell death, cellular death, your red blood cell death, bleeding. They call it sloughing of your intestinal mucosal cells, so the cellular death, so losing cells. And also if your villi in your duodenum are not of the right height, so to create that big absorptive surface, then you cannot absorb your iron properly. So then you could be at risk of an iron deficiency. So if your villi are stunted or shortened due to, there are many factors, one of them being dairy intake, and if you're lactose intolerant, although that shortens your villi in your intestinal mucosa. So those are some of the things that can lead to losses of iron. And then, as I said, your red blood cells are mainly used in your iron is mainly used in your red blood cells, your liver, your muscles, and your macrophages. So your macrophages form part of your immune system. Okay, so then iron is essential for your cellular metabolism. So the iron is what goes into your blood that forms that circle with the iron in the middle, and it takes your nutrients all over your body. So if you have no iron, you cannot move the nutrients. So your metabolism, your cellular metabolism will not be working. So aerobic respiration, so meaning air intake and moving your oxygen throughout your body, is also needed for iron is needed for that. But your cellular iron overload can lead to toxicity and cell death via free radical formation and lipid peroxidation. So if you have too much iron, you can also cause damage through free radical formation. So that is why people who are sick should not be taking iron supplements, because iron is a place or a key food for bacteria. Bacteria can thrive on iron. So free radical formation and lipid peroxidation. So your fat's going rancid. Iron basically makes your fat go rancid. So too much iron is extremely bad for your body. So you want that balance. So we don't want too much iron, we don't want too little iron, we want the balance. But when you get too much iron, you are at risk of infections and getting more serious disease. So it's best to not take an iron supplement when you have a disease. So that's also why we don't prescribe iron to someone who's in the ICU generally. So homeostasis and tight regulation of your iron is extremely important because of these key points that I've told you about. So you get two kinds of iron, heme iron and non-heme iron. So non-heme iron is basically the plant-based form. Heme iron is the animal form. So the only difference is the heme iron is already Fe2+, and your non-heme iron is Fe3+. So Fe3+ needs to be turned into Fe2+ in the body so that it can be used effectively. So it's just not in the active form. So these two, heme and non-heme iron, are also absorbed through different pathways. So it's possible to get both. So non-heme iron, like I said, is Fe3+, and has to be converted to Fe2+, and it's used and transported across the intestinal epithelium. Transporter molecules that transfer this Fe2+ also transport zinc, copper, and cobalt. So there can be competition for these transporters if you are taking in too much copper, cobalt, or zinc as well, because they use the same transporter across your cell. Heme transport, they do not know how that works, basically. Non-heme iron, they know the mechanism of how it gets transported in the body, they know how it's absorbed, they know how it's switched from Fe3+ to Fe2+, but heme iron, there's not enough research. So non-heme iron can be absorbed in your body and can be used, and it's sufficient for your needs, basically. Then there is also an interesting fact that I found out when I was doing the research for this video, that if you have a high heme intake, you can increase your iron levels to such an extent that you increase your risk of type 2 diabetes. So a high heme or animal product intake can increase your risk for diabetes, where your non-heme does not have that risk. So your liver can be damaged by an overload of iron because of this oxidative damage, and because too much iron is going to be put into your liver. It can cause a similar disease as alcoholic cirrhosis, so your liver hardening, your cells dying off, or it can cause a carcinoma, so cancer of the liver, and that is not good at all. So we really don't want an increase in our iron intake to dangerous levels. You really want to maintain the balance. So I would not recommend an animal protein intake because of this, and because it increases your risk for the metabolic diseases, and it increases your risk for so many other things. So iron is stored as ferritin in your liver, and then it binds to transferrin to move around your body. So the absorption also depends on your liver storage. So your duodenum and your liver work together to maintain the balance, and the signals that they are sending will determine how much of the iron is absorbed from your stomach, from the food that you are taking in. So factors that influence your absorption of iron is inflammation, hypoxia, current anemia, so you get different kinds of anemias, and the current stores. So hypoxia meaning oxygen. Okay, so I was telling you the factors that influence the absorption: inflammation, hypoxia, anemia, and the actual stores that you have in your body at that moment. So inflammation is key. So you can either be consuming a pro-inflammatory or an anti-inflammatory diet. So an anti-inflammatory diet would be a whole food plant-based diet with decreased amounts of processed products, where a pro-inflammatory diet would be one rich in animal products, in processed products, fast foods, and drinks, for example. So hypoxia is your oxygen level in your body. So that is maintained by the lungs. So you need to be breathing deeply to get the right amount of oxygen in, so that your blood can be oxygen rich, so that you can send that throughout your body and especially your brain, so you can think clearly. You want proper oxidation in your brain for it to be functioning well. Then another one is hepcidin. Hepcidin is a 25-string amino acid cysteine-rich peptide, or kind of a protein. It's antimicrobial, but hepcidin determines your oxygen, your iron absorption. So high hepcidin leads to a low iron. So a low hepcidin, higher iron absorption. So you want your hepcidin to also be balanced, so that you are not taking in too much or absorbing too much iron or too little iron. So hepcidin is made by your liver, and it's excreted via the kidneys. So it's also a key component in your iron homeostasis or balance. So when you get your iron tested at a hospital or by the doctor, you need to also look at these other things: your hepcidin levels, your liver function, your kidney function, and your inflammation and oxidation in your body. So your body has about 4,000 milligrams stored in your blood of iron. Then about 1,000 milligrams stored in the spleen and the liver, and you have about 3 milligrams in circulation. So the total amount is 4,000, about 2,000 to 3,000 in your blood, about 1,000 in your spleen and your liver, and a tiny amount, 3 milligrams, is circulating in your blood. So that circulating amount needs to be replenished every single day, because you are losing 1 to 2 milligrams of iron per day. So you need to be absorbing a little bit more than that to maintain that balance. So you are always losing iron out of your blood because of bleeding, because of cellular death, cellular regeneration, that constant movement in the villi in your intestine as well. So a guideline is a 10% absorption of the amount of iron that you're taking in. So if you're taking in 15 milligrams of iron, you'll be absorbing anything from 1.5 to 2 milligrams. So that's about the bottom limit. You cannot be absorbing more as well, depending, as I said, on your liver, your duodenum, and your hepcidin levels. Then also know that processing severely influences your iron content, especially in grains. Processing of grains really tanks that iron content. So you really want to take in an ancient form of a grain, or the whole grain, the proper whole thing. Otherwise, you're not getting the desired iron. And like I said, high heme iron intakes can lead to an increased risk of type 2 diabetes and the other metabolic diseases, because it can push your iron levels a little too high. And a high iron level in your body can also influence your immunity. It can decrease your immunity, and it can cause infections in your body. So that's why dietitians will not prescribe iron to someone who's in the ICU, for example, generally. Okay, so then, why do we need iron? So as I said, iron is needed for enzyme function, for blood function, for your red blood cell formation and production, your red blood cell health, oxidation of your blood, transport of all the molecules in your blood, because without iron you cannot be transporting nutrients. And iron is also essential in erythropoiesis, which is producing EPO. And EPO is the hormone that increases or stimulates the production of your cells. So cellular production is reliant on EPO. If you can increase your EPO, you can increase the amount of cells that are being made all the time. So in essence, you can speed up your healing, you can speed up recovery, you can speed up oxidation, you can have more oxidation in your body, and you can move nutrients better throughout your body. So EPO is essential to your body. That's why some sports people will try to artificially increase that EPO so that they can recover more quickly. So iron also stimulates EPO production, which stimulates blood cell production. Okay, so we're almost at the end of the video. So I've just got those little bonus tips on how to increase your iron absorption. So vitamin C increases iron absorption. So if you are eating an iron-rich meal, beans or peas or lentils or spinach or beetroot, add something like an orange or orange juice or strawberries or guavas. They're all high in vitamin C. So some things that can decrease the amount of iron that you absorb: tannins and calcium. They will decrease iron absorption. So I hope you enjoyed that. You got some benefit from it. If you did, please leave me a comment, subscribe, hit the bell, share it around as well. It would be much appreciated. I want to reach as many people as I can, because knowledge is power, and we can prevent disease when we have knowledge about our bodies and about the things that we need to keep us healthy. So as always, stay healthy, and to God be the glory, and see you next time. Have a healthy day.